Alrighty. So this is another recording. This one is related to the math in Unit 2. So there's a couple of concepts that we're going to talk about here, molarity and molality. So they sound really close to each other, and honestly, what they're calculating is really similar to each other too. So come up with some way or another to remember what to do if the question asks for molarity and if the question asks what to do for molality. So there's nobody here, so this question can't be answered by you guys, but if I were given $1,000 and the responsible thing would be put it towards bills, which is probably what I would do. But if I had to use it for something fun rather than the responsible thing, I would probably buy wood, so then I can do some more furniture building, or maybe a combination of wood and a planer, because I don't have a planer. And I found this really cool wood store that has natural wood that kind of needs planing before you can use it, but they have a way bigger selection than your typical like Lowe's or Home Depot. All right, so you are the kid at Hope. You are talented, smart, and capable of success. You have dreams for the future, and you will climb to reach those goals and dreams every day. And doesn't really apply since I'm the only one here. All right, so you're going to learn about molarity and molality and how to do some basic calculations with them. All right, so the big thing is to make sure that you know the difference between them so that you know the right way to use them. So I'm going to start with the both column. Both of these are ways to quantify, give a number to the concentration of a solution. Okay, because so far we've talked about we can call a solution dilute, we can call a solution saturated, but sometimes you need to be more specific than that. Maybe you need to know exactly how much solute is dissolved into that solution, and that's what we use these for. Another thing that you may have to do with these is convert your molar masses to moles, because if you notice, both of them are moles per something. All right, so if you, just as a quick review, for example, if you needed to figure out the molarity or molality of how much carbon dioxide is dissolved in soda pop, all right, we've got carbon dioxide, CO2. The molar mass of carbon dioxide is going to be, you go to your periodic table, look up the mass of carbon, look up the mass of oxygen. Carbon is 12 grams, like 12.011 or something like that. Just round it to the nearest whole number. And oxygen is 16 grams. Again, it's like 16 something or 15.99. Round to that whole number. What you do is you add 1 carbon plus 2 oxygens, so 12 plus 16 plus 16, which would be 44 grams per mole. Right? Then, say you are told that there is 24 grams of carbon dioxide. Right? How you're going to calculate your molar mass here is you are going to divide by, or sorry, how you're going to get moles, you're going to divide by the molar mass. Because what that's going to look like is this. Oops, I do not need straight line tool. I need random line tool. So if I set up parentheses here, all right, so I've got this fraction really here. I've got 44 grams over 1 mole. So I'm going to put the 44 grams on the bottom. And the 1 mole on top. And what you end up doing is canceling out grams and converting to moles. All right, so it'd be 24 divided by 44, which is gonna be not quite 1/2, but almost, so probably like 0.48 or something. I don't have a calculator on me at this moment, but I'm gonna need one. There we go. So 24 divided by 44 is, nope, just kidding. This is why you don't do math in your head. That equals 0.54 moles of CO2. Okay, so if you're converting from grams to moles, you divide by the grams to get moles. So you divide by your molar mass. All right, so now let's look at the two separate things. So we use molarity and molality to quantify concentration. And a skill you may need to do this is being able to convert a mass to moles using molar mass. Now, molarity is the number of moles in 1 liter of solution. Okay, the number of moles in 1 liter of solution. That's just kind of the basic definition. So what that means, if you needed to find the molarity of a substance, you would need to know the number of moles of your solute, and you would need to know the volume of your solvent in liters. All right, so to calculate molarity, you take your moles of solute and divide by the volume of your solvent. All right. When you write this out to indicate what you're saying, and you guys have actually seen this before on your bottles, your chemical bottles. The concentration is written, you give the molarity number, so say 4.5. The unit for molarity is a capital M, and you say what it is. Okay, so this would be 4.5 molar hydrochloric acid. That's what HCl stands for. Okay, so the key is with both of these, you need to include the unit, but also what it is. So it's like, yeah, 4.5 molar what? What are we dissolving? Okay, so molarity, trying to think the best way to probably remember this. Molarity, the big difference is that it has an R, because molality has an L in there instead. And liter has an R in it. So molarity is the moles per liter. All right, so you have your moles divided by your volume in liters. Molality, on the other hand, is the number of moles in 1 kilogram of solution. All right, so here you're going to take moles of solute and divide by your mass of solvent, and that mass needs to be in kilograms. All right, so if you had calculated the molality to be 4.5, that would be 4.5 little m HCl. So 4.5 mole, MOLAL, hydrochloric acid. All right, so the unit here is little m. Now, as a quick review, we've seen this unit before. Little m means meter. So this is, again, a really important reason why you have to sit there and throw the chemical that you're dissolving at the end. All right, otherwise it looks like you're giving me a length. So make sure that when you write these out, if you're writing it for a written part of the test or something, that you would do 4.5 little m and then what the chemical formula for the substance you're dissolving. All right, let's see some of these in action. And we actually already covered that. So a molarity problem is we have 450 grams of lead chloride that is dissolved in 400.450 liters of water. What is the molarity? All right, so just as a reminder, we know molarity is moles of solute over your liters of solvent. So can I use both of these numbers as is? You should be saying no or yes and no. So we have to do something with this number, because this isn't in moles, this is in grams, but our volume is at least in liters, so we're ready as far as our volume goes. If you ever get milliliters, you may have to convert that. So the task we need now is to figure out what's the molar mass of lead chloride. Periodic run. So I have a program on my computer that saves links or saves really quick copy paste things. And because my periodic table link isn't in there anymore. Let's get one for you guys. Sorry. Normally I would have this ready. And I unfortunately cannot pause this recording. But I really, really, really like this periodic table that I share all the time. So I want to share the same one instead of just finding a random one. Of course, nothing's working this morning. Almost there. Okay, so this won't be live because this is a recording. And it's not through Blackboard. But so find yourself a periodic table. And you can see everything I was doing too. So on here, we're gonna find lead, which is right here. So that has a mass of 207. And chlorine is over here, has a mass of 35. So let's write that on the board. So we've got 207 plus 35 plus 35. All right, so if I add that together, that's 277. Don't even need my calculator. 277 grams per mole. All right, so in that case, I'm going to take my 450, I can type correctly, grams divided by 277 equals that. I do need a calculator for 1.6245, blah, 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 blah. So I would use 1.62, since that's followed by a 4, I don't need to round up, moles. All right, so now that I have the two numbers that I need, I have my moles of solute, my volume. I'm going to finally plug this into my equation. I'll have 1.62 moles divided by 0.45 liters. And that gives me 3.61. I didn't end up rounding for my number before, so if you get 3.6, that's okay. Equals 3.61. And how should I write this out? All right, what's the unit for molarity? Hopefully you are saying capital M. And then what else do I have to remember to include? So afterwards, you want to put the formula, the chemical formula for the substance that you are dissolving, for your solute. So it'd be PbCl2. All right, so that's molarity, moles per liter. Molality, on the other hand, you can dissolve 329 grams of sodium chloride in 12 kilograms of water. What is the molality? So again, let's just write down how we figure out molality. It's the moles of solute divided by the mass in kilograms. So what is nice, mass is already in kilograms, but again, we have a mass of solute, so we have to convert that to moles. So we need to figure out what is the molar mass of sodium chloride. So go back here, got sodium, 22.99, so we're going to call that 23 grams, and then chlorine we already used was 35. So we've got 23 plus 35, which is equal to 58. Yes, grams per mole. Then we take our 329 grams, divide by the 58 to get our moles. This I need a calculator for. 329 divided by 58, 5.67. All right. So now I can finally plug this in. I have my moles of solute, so that's this 5.67. In kilograms of the solvent. So this is going to look like 5.67 moles over 12 kilograms. So 5.67 divided by 12 is 0.47. And molal. What was that unit for? Molality. Right? That was the lowercase m. Now, if I left it here, that would look like I was giving you a length. What do I need to include at the end to make sure that this communicates out as a concentration measurement, molality? Hopefully you are saying sodium chloride or the formula. Right? So the formula of the substance you are actually dissolving. Okay? So here is your assessment for this. All right, what I want you to do, you've got 6 items over here. So this isn't the full chart, but I want you to assign these to something specific to molarity, something specific to molality, or something that they have in common. All right, so you don't have to do this in the chart form. This is just built for if I had you guys live in class, you could drag them. But in an email, you can send me, molarity and then the items that are related to molarity, both the items that are related to both, and molality, the items that are related to molality. And then you get to choose one. Choose one of these to actually do the calculation for. Both of them require you to do a molar mass, all right? Key is, gotta show me your work for it to count. Okay, so I want to make sure, because it's one of those things, you show me your work, you make a mistake, I'll probably still give you credit for having attended class and then just explain the mistake. But if you just give me an answer, there's nothing I can really do to help you. Okay, so show me your work, and then either you won't make a mistake because sometimes showing your work actually helps you remember to do everything, or if you do make a mistake, I can easily help you correct that mistake. So I hope this helps with those calculations.